Okay, so we are continuing on with talking about three-dimensional shapes. I'm going to be on page 590 here in just a minute, but at first I want to talk about a little bit about area. So when we're finding our area of a circle, what we're doing is we're figuring out how many square units I could fit in that circle. Hence why we always label area in square units or like inches squared, because we're figuring out how many squares fit inside the circle. Well, the same thing goes for when we talk about volume. And when we talk about volume of like a cylinder, like we're going to today, we talk about how many cubes I could fit in that three-dimensional figure. So if I filled this figure up, I could fit one layer of cubes right there all the way across and inside, and then I could fit another layer all the way inside. So when we talk about volume and labeling volume, we're going to talk about cube units because we're figuring out how many little cubes I could fit inside this cylinder. So with that being said, let's go to page 590 and we'll talk about the formula. All right, so volume is the measure of space occupied by a solid. So in other words, like I was saying, how much can I fill up in this three-dimensional shape, because I can actually put things in there. It's measured in cubic units, which is why we're trying to figure out how many of these little cubes we could fit in there. A cylinder is a three-dimensional figure with two parallel congruent circular bases. So circular bases, so I have a base of a circle there, and then obviously on this end I would have a base of a circle there. And they're parallel to each other because they would never touch. Connected by a curved surface, the area of the base of a cylinder tells the number of cubic units in one layer. The height tells you how many layers there are in the cylinder. So in other words, what it's saying is like the base of this, if I figured out the base of this, I could figure out how many cubes I would fit on that first layer. And then I would just take that times the height, which would tell me how many layers of that I would have. All right, so I'm going to skip down to got it A. I should talk about the formula first, which is up here. So this is where I would have you guys get out your reference sheets and we would all look at the volume of a cylinder. But it is actually right here at the top of your page. To find the volume of the cylinder, we're going to find the base times the height. Now, when we talk about the base, we're going to find the area of the base and then take it times the height. Well, to figure out the area of the base is a circular, so we find the area of a circle, and then we take it times the height. So that is where we get these two different formulas. The volume is the big base times height, where our base is the area of pi. So in other words, we really take pi r squared, this would be the base, which is our circle, times the height of the cylinder, which would give us how many layers we need. So now let's go down to the bottom of the page and do got it A and B together. So got it A, we need to find, I'm just going to write the formula down here. We have volume equals pi r squared, that's our base of our cylinder, times the height. So this right here, since it only goes halfway across that circle, that is going to be our radius. So we're going to take pi, which we're going to say is 3.14, times the radius squared, which is 3 squared, times our height of our cylinder is 1.8. So now I just use PEMDAS to solve. So I would do squared first. So 3 squared is 9 times 3.14 times 1.8. And I'm just going to do that all in one step. And I'm just going to type it in my calculator. So I got the volume to be 50 and 868 thousandths inches, and I'm talking about cubes, so cubed. I'm going to round this though to get my final answer. I'm going to round to the nearest tenth. So the 6 tells the 8 to go up, so my final answer is going to be 50 and 9 tenths inches cubed. All right, on B, we are given the diameter and the height. So remember, when you're given the diameter goes clear across your circle, but we only want the radius, which is half. So to figure out my radius, I'm going to take 12 and divide it by 2 to figure out what half of that is, which is 6. So now I know that my radius is 6 millimeters. And now I'm just going to plug things into my formula. My formula stays the same. So I have pi, which the volume equals pi, which we're using 3.14, times the radius, which we found to be 6 squared, times the height, which we're given is 5. So again, I do orders of operations. I do exponents first. So 6 times 6 is 36. And then we still have all of this. I'm going to type it all into my calculator in one step. And I got the volume to be 565 and 2 tenths, and I'm going to label it millimeters cubed. And I don't have to round because it's already in the tenths place. So that is my final answer. All right, I'm going to do one more example with you. I'm on page 591. I'm looking at Got It C. So it says the Roberts family uses a container shaped like a cylinder to recycle aluminum cans. It has a height of 4 feet and a diameter of 1 5/10 feet. The container is full. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot? Round to the nearest tenth. So this one has a little bit of extra steps. So first of all, let's underline the stuff that we know. We know that it's shaped like a cylinder, and we know that it has a height of 4 feet and a diameter of 1 5/10 feet. We also know that the container is full, so that means the volume is at max. How much do the contents weigh if the average weight of aluminum cans is 37 ounces per cubic foot? Round to the nearest tenth. Okay, so first of all, let's just find what that volume of that container is. So we're going to use the formula. Volume equals pi r squared, that's the area of our base, times its height. So I have 3.14 times the radius. Now we were given the diameter, and the radius is half of that. So I would take 1.5, I'm going to write it over here, 1.5, and divide by 2 to figure out my radius. And that's 75 hundredths. So times 75 hundredths squared times the height of the can, which is 4 feet. Okay? I'm going to do 75 hundredths squared. So 75 hundredths times 75 hundredths gives me a not pretty decimal. And I'm going to multiply that times 3.14 and 4. Again, I'm just going to do it all in one step in my calculator. So I got the volume to be 7 65 thousandths. So that's what the volume is of that can. But now we want to know what the how much it weighs if I have 37 ounces per cubic foot. Well, since I have 7 65 hundredths cubic foot, I would take my volume times the weight per ounce, which is 37, and I get an answer of 261 and 405 thousandths. I'm just going to round it to the nearest tenth. So the 0 tells my 4 to stay the same, so my final answer is 261 4/10. And since we're talking about the weight, we would say ounces. All right, so your homework for today is actually to flip forward to page 595, and you are going to be doing numbers 10, 11, and 12. It does not have an example or does not have a problem like the example we just did, because I would like to do some more practice problems, but I wanted you to see how we would use volume to figure out weight of objects. All right, get your assignment done and have a great weekend.